and obtain gain crossover frequency, phase crossover frequency, gain margin and phase margin. What is our given data? Open loop transfer function g of s equal to 20 divided by s into 1 plus 3s into 1 plus 4s. What is our first step? Substitute s equal to j omega. We have to do the frequency response analysis. G of j omega, which is equal to 20 divided by j omega into 1 plus 3 into j omega into 1 plus 4 into j omega. Just we can substitute s equal to j omega here. Here 1 plus s into t format we have here two term is here, so we have to calculate the two corner frequency omega c1 and omega c2. Here the first corner frequency is an 4, it is an t value s into t 1 by t, here it is in 4, this 4, the coefficient of j omega is an t, so we can consider this is an t, so we can find out omega c1, it is in 0.25 radian per second. The second corner frequency, this is what our second term, omega c2, which is equal to 1 by 3, which is equal to 0.33 radian per second. Next we have to calculate the corner frequency and the slope. First we have to take the term 20 divided by j omega. There is no corner frequency because it is a constant term, so it is no corner frequency. The slope is minus 20. This change in slope, there is no change in slope. And next we have to take the 1 divided by 1 plus j into 4 omega. The corner frequency is 0.25, we found out already. The slope in dB is in minus 20 dB. Here change in slope is this 20 dB and this 20 dB. We can add these minus 20 and minus 20. We have to get minus 40. It is a change in slope of this term 1 divided by 1 plus j into 4 omega. Similarly, we have to get it is in 3. This is in 3. 1 divided by 1 plus j3 omega. We have to get the corner frequency is in 0.33. Here also we have a slope 1 divided by 1 plus st format, we have a slope is in minus 20. So we can have a previous slope is in minus 20, here this slope is in minus 20. So totally we have to minus 40 plus minus 20, which is equal to minus 60. It is a change in slope of 1 divided by 1 plus j3 omega. Next we have to choose the omega L value and omega H value. How we can choose omega L and value and omega H value means omega L should be lesser than omega C1 and omega H is nothing but it is greater than of omega C2. In this problem we can consider, it is what our assumption, omega L equal to 0.15 radian per second. Why? Because of our omega C1 is in 0.25. We can taken out, okay, so we can 0.15 we can taken here, and 0.33 we have, it is an omega C2 greater than the omega C2, we can assign omega H value, so we can consider it as 1 radian per second. Next we have to calculate the gain value. What is the gain value? Modulus of j omega, which is equal to 20 log of 20 divided by lower frequency, it is an omega L. We know the lower frequency is 0.15, so we can get a value 42.5 dB. At omega equal to omega C1, we have to find out 20 log of 20 divided by omega C1. Omega C1, which is equal to 0.25. At omega C2, we have to calculate change in slope from here. In the previous two terms there is no change in slope, there is no change in slope, here there is no change in slope, so we have to calculate this only. Yeah, to omega C2, change in slope from omega C1 to omega C2 into log of omega C2 divided by omega C1 into gain of the previous omega C1. Slope from omega C1 to omega C2 equal to minus 40. Omega C2 equal to 0.33, omega C1 which is equal to 0.25. The previous decibel value is the gain of the omega C1 at omega C1. It is in 38. From this value we have to substitute here, it is an 38. Okay, don't confuse, this is already we found omega c1, we can substitute omega c1, we have to get 38 dB. That 38 dB we want to substitute at this point. Gain value at omega c1, it is an previous value. Suppose this value is wrong, means the entire problem will be wrong. We care about omega c1 calculation. And next, omega which is equal to omega h, gain value which is equal to slope from omega c2 to omega h into log of omega h divided by omega c2 into gain of the omega c2. Here the gain of omega c2 which is equal to 33 dB, so we can substitute 33 here. Okay, here change in slope is a minus 60 into log of the omega h value, we can consider it as a 1. Already we said omega h is higher than the omega c2 value. Omega c2 is in 0.33, the higher value we can consider as 1 here, and plus gain value of omega c2, it is in 33. Finally we have to get 4 dB. Next, phasor plot. Phase plot we have find out 1 divided by j omega is there. It means 20 divided by j omega. There is angle, phasor angle is minus 90. 1 divided by s plus 1 plus st means we are have a tan inverse of 3 omega. Why we can consider tan inverse of 3 omega? Tan inverse of imaginary part divided by the real part, it is an 3 omega. Similarly, 1 divided by 1 plus st, here t is in 4 into j omega, so we can consider minus tan inverse of 4 omega. Let us consider omega, we have assumption 0.15 value we have, 2 value we have, 0.25, 0.33, 0.66, up to 1 we have. Or 4 or 5, 6 or 6 or 7 values we can choose as a omega value and substitute omega value here 0.125. What is the pi value? This is an 140 minus 146. Similarly, we have to calculate all other terms. Okay. Next, come to our graph. Listen, we have a 20 dB. This is what our minus 20 slope. It is a first slope, and this is our second slope, and this is our third slope. Okay. Here change in slope is a minus 20, minus 40, minus 60. This is what our slope. Okay. Next, this is a magnitude plot. Similarly, we can change the pi angle. Here we have considered as the omega and pi. We have to draw the one of the graph. Similarly, how we can calculate the magnitude plot, g of j omega versus our change in slope, the term and the change in slope. Okay. From the graph we can understand this is a magnitude plot, this is a magnitude plot, and this is an phase plot. Okay. The gain value, we have a gain value 33, 38, and so we have to find out the slope. And next, substitute the omega value versus the pi value. We have a draw on graph. This is an phase plot. What is our next condition? Next term, we have to find out the gain crossover frequency. What does mean the gain crossover frequency? The 0 degree line of magnitude plot. We can draw the 0 degree line. Here we can draw the 0 degree line. That line is cuts our magnitude plot, and the corresponding value it is called as an gain crossover frequency. It should be our gain value equal to 1.1 radian per second. Here we have to get 1.1 radian per second. Similarly, we have to find out the phase crossover frequency. We have to draw the 180 degree line, minus 180 degree line. Here minus 120, 140, 160, it is a minus 180 degree line. we have to draw the 180-degree line that cuts a magnitude plot. Corresponding line we have to draw, that means this line we have to draw. At that point we can consider it cuts the one or magnitude plot. It is, that value is called as an phase crossover frequency. It is an 0.28 radian per second. Listen, this is an 0.25 and this line is an 0.28. We have to calculate gain crossover frequency and phase crossover frequency. How to calculate gain crossover frequency? We have to draw the 0-degree line or 0-degree line to the magnitude plot. That line, that 0-degree line cuts our magnitude plot. The corresponding value, the corresponding value is nothing but a gain crossover frequency. Similarly, we have to draw the 180-degree line of phase crossover frequency. That line cut the one of the magnitude plot. That value is called as a phase crossover frequency. Okay. Next we have to find out the gain value. This is what our gain. Phase value, and first we have to calculate the magnitude. First we have to calculate the gain crossover frequency and phase crossover frequency. The gain margin is that minus 180-degree line. We have to cut the magnitude plot and the corresponding degree value and gain value should be considered as our gain margin. This is what our gain margin value. Next we have to calculate a phase margin. Formula is an 180-degree plus gain crossover frequency. Here gain crossover frequency is an, here our 0-degree line cut our magnitude plot, that cuts our phasor plot. That value is called as our gain crossover frequency. Here the gain crossover frequency is in 244. The last line, this line we have to cut, this part we have to cut. Our degree is an 244. We have assumption. Finally we have to get a phase margin is an minus 64. Gain margin and phase margin we have a negative value, so the given system is an unstable system. We can conclude from the phase margin and gain margin we are have. If suppose we can get a gain margin and phase margin, we have a positive value, the system should be unstable. Here we have to get an negative value, so the system is an unstable system. Thank you.